Welcome to a deeper dive into data visualization, a crucial skill for anyone working in machine learning. We often think of charts as just ways to present results, but today, we're exploring them as powerful tools for discovery, uncovering patterns, outliers, and relationships that are absolutely essential for robust feature engineering and profound model understanding. In the world of machine learning, your model is only as good as the data it's fed. Before you even think about algorithms, understanding your data's underlying structure, potential issues, and hidden connections can make or break your project. Basic bar charts and pie graphs have their place, but to truly gain insights for ML, we need to go beyond the surface. Let's kick things off with a foundational tool, the histogram. A histogram visualizes the distribution of a single numerical variable by dividing the data into bins and counting how many data points fall into each bin. It's like a bar chart, but the bars represent ranges, not categories. For machine learning, histograms are invaluable for quickly grasping the shape of your data. Are your features normally distributed? Skewed left or right? Do they show multiple peaks, indicating different subgroups? This understanding helps in deciding whether to apply transformations, identify potential data entry errors, or understand if your model's assumptions about data distribution will hold true. Next up, we have box plots, also known as box and whisker plots. These provide a concise statistical summary of a numerical variable's distribution, showing its median, quartiles, and potential outliers. The box itself represents the interquartile range, from the 25th to the 75th percentile. Box plots are fantastic for identifying outliers and comparing distributions across different categories. An outlier, typically a point falling beyond 1.5 times the IQR from the quartiles, could be a genuine extreme value, a measurement error, or an anomaly that needs special handling in your model. Comparing box plots for a feature across different target classes can reveal if that feature has predictive power. Moving on to relationships, scatter plots are your go-to visualization for exploring the connection between two continuous variables. Each point on the plot represents an observation, with its position determined by the values of the two variables. With scatter plots, you can visually assess correlation. Is there a linear trend, or perhaps a nonlinear relationship? Do data points cluster together, suggesting distinct groups? Identifying these relationships is critical for feature engineering, as it can inspire the creation of new interaction features or reveal multicollinearity issues that might affect your model. While histograms show counts in bins, density plots, often generated using kernel density estimation, provide a smooth, continuous estimate of the probability density function of a variable. Think of it as a refined histogram, less susceptible to binning choices. Density plots are particularly useful for comparing the distributions of multiple variables or the same variable across different groups. Overlapping density plots can visually highlight differences in means, variances, and shapes between classes, offering insights into how well a feature might separate your target variable. This is a powerful technique for feature selection. Finally, let's talk about QQ plots, or Quantile-Quantile plots. These plots are used to check if a dataset follows a particular theoretical distribution, most commonly the normal distribution. They plot the quantiles of your data against the quantiles of a chosen theoretical distribution. For machine learning, QQ plots are vital because many statistical models and techniques assume normality. If your data points closely follow the straight line on a QQ plot, it suggests a good fit to the theoretical distribution. Deviations from this line indicate non-normality, prompting you to consider transformations or models robust to non-normal data. The true power of these visualizations comes from using them together in an iterative data exploration workflow. Start with histograms and box plots for individual features, then use scatter plots to explore relationships between them. Employ density plots for class comparisons, and QQ plots to validate distributional assumptions. This holistic approach builds a comprehensive understanding of your data. By mastering these powerful visualization techniques, histograms, box plots, scatter plots, density plots, and QQ plots, you move beyond simply looking at data to truly understanding its nuances. These insights are not just pretty pictures, they are the bedrock for effective feature engineering, informed model selection, and ultimately, building more accurate and interpretable machine learning models.